All right, so on your review, does anybody have any questions about page 1 on your review? Anything on page 1 that doesn't make sense to you? We talked about, extensive properties, intensive properties. Yeah.
Can we go to the table at the bottom of page 1?
Which I think is, yep, here we go. Okay.
What did it say in the liquid row volume?
The volume is definite. Like
definite.
measure. You can measure it. It's going to stay the same as opposed to its shape. Its shape is variable. It's going to change based on the container that it is in. When you get to a gas, it's going to take the shape and the volume of the container. Does that make sense? Because they're going to spread out as far and wide as they possibly can. So the word is definite. I think I have a cursive F in there, so sorry about that. I recognize that at some point, we were talking about that in AP today. I recognize that at some point it's going to get to where I can't write in cursive anymore because they haven't taught cursive. So maybe that's my sign that I need to retire. All right. What do y'all think? Good. What else do we have questions about? Anything else that doesn't make sense on there, sir?
Can we talk about the noble gases?
Noble gases. So I don't know, and I think we may have actually pulled that question out of the exam. It's on page 1. Okay. There it is. It's number 7 on here. Yeah. So your noble gases are on your periodic table. If you look at your periodic table, you have a kind of a column here, and then it indents, and then you've got a broader set of columns over on this side. Okay. And it is this last column on your periodic table that are your noble gases. So this guy right here. And the reason why they're called noble gases is because they're not going to interact with other substances. They don't form compounds for the most part. Okay. There's a couple rare exceptions, and we talk about that in AP Chem. But as far as this course is concerned, just know that they don't interact with anything. And we're going to get into why that is. Essentially, the reason why elements react with other elements is to fill their electron level. Remember, you've got a nucleus, and then outside that nucleus, you've got electrons out here. Okay, and those clouds, you talked about this before in other science classes, I hope, how atoms are structured. Okay. So the reason why they bond is because oftentimes for anything that's not in this last column, there's always spots here that they need to fill. They want to get those filled up. Okay. And they will bond in such a way to make that happen. Well, these guys at the end of the periodic table are already filled. So they don't react with anything else. That's why they're called a noble gas. So if you have a sample of helium, for example, it's not going to react with anything. Okay. So atoms that don't react, they're in the last column, and they call them noble gases because, like the nobility, they won't interact with the common folk. So that's where they got the name. Sometimes they're also called inert gases. That's another word you'll hear for them. Inert means that it doesn't react. So if something's inert, it doesn't react. Okay. I don't believe, I'm 99% sure that got pulled off of this test. So I wouldn't worry about it too much. It will probably be on your next test though. So, or the next one. I don't know. It comes up later on. So, but we're just previewing it now. Okay. What else? Anything else on page 1? How about page 2? Anything on there that doesn't make sense? Yep.
I'm confused about the illustrations with the mixture.
Okay. So we talked about how we have things that are the same throughout. Okay. And we talked about different types of mixtures. So this is a mixture here. Okay. I'm confused about this one myself right here.
Yeah, that's right.
Okay. Yeah, we can talk about that one. I think that's mislabeled. I think that should be an E. So these are different size particles here. So that's why this one's classified as heterogeneous. This one's homogeneous. It's a mixture of two different elements. This is just an element down here. These are all the same. It's even throughout. This, I would say, is heterogeneous because it's got two different layers. Okay. So I think, again, that there was an issue with that. So.
Wait, so the first one, A, is also heterogeneous?
Yep, these are both hetero.
Right.
This one because it has different size particles, and this one because it has two different layers. Homogeneous substances tend to have the same particle sizes, and they're very small. All right, what else? What other issues did you find? See, I just throw those problems in like that. You know, I intentionally put errors in the answer key so that I can see if you're on your toes. Anybody buying that?
No.
No. Had to try. That's what happens when you have a smart audience. You can't pull anything over on them. All right, what else do you want to talk about? Anything else, page 2? All right, how about page 3? Some year I'll get all of this stuff fixed and then I'll retire. All right, so page 3 made sense? No issues there? Problems? Nothing confusing? Yep.
So, like, do the orders of mass A and mass B matter?
Where are we at here? This guy here?
Yeah, like, there was a chart. Like, yeah, there's a table.
Oh yeah, that I want to check that out.
Yeah, because the mass of A is different than the mass of B, but you kept
Are you
using
talking
the
about
word-
this here?
Yeah, you kept
Oh,
using the word
okay. I think that's
ratio.
on the next page. Okay. All right. That's why I couldn't find it. Okay. Yeah. So no, you're just looking at percentages here.
Okay.
So, so if you're looking at percentages here, nothing else has 20%. So there's no, none of these are the same things because none of the percentages are the same. And I think for your test, we made everything the same number of sig figs just to make life easier. I think we've revised the test to make it nicer.
Yeah, I was under the impression that, like, sample 1 and sample 4 were the same substance.
No, if the only way that that's going to happen is if A is 20%.
Okay. So,
Because
like,
this is like saying, you've got dogs and cats, right?
Okay.
You got dogs and cats. Here you've got 20% dogs and 80% cats. Here you got 80% dogs and 20% cats. You're not going to have the same things in that mixture. Does that make sense? So no, it's not the same substance.
so I kept my answers.
And I think that there is something very, very similar to that on the test.
I think it just threw me off that it was like A and B and not a definite thing.
Yeah. Well, think of it as dogs and cats if you need to. 20% dogs, 80% cats. It's a bad day. 80% dogs, 20% cats. It's a better day.
Is it the...
Definitely. No, Annika's on with me. Yeah. 0% cats would even be better.
Wow.
And then I think I had a couple extra down here that you didn't have. And then there was this guy. These are the ones that you should have had on the answer key, and yet you didn't because Lippy can't get anything right. She thinks she does, and then she doesn't. Okay, so remember how we do these. I'm going to try to pull this out. Does it have a 150? Yeah, there we go. So when we are doing these, you're getting the masses off the periodic table. That's where I got this first column of numbers. These are how many atoms you have in that formula. So 3 times 1 is 3. Hydrogen is 3 times 4, which is 12. And then I multiply across for all of these. Then I go through and I add that column up to get my whole. And then for each one of these, I do part divided by the whole. Part divided by the whole. And then that's how I get my percentages. And I usually go to the tenths place for my percentages. Yep.
And you also multiply by 100.
Yeah, multiply by 100. I do that so automatically that I just don't even think to include that. So, yeah, I'm sorry. So, yeah, part divided by the whole, and that would be times 100. Yeah. Okay, better? Bad, Lippy. Bad. So you say that to a dog and they'll feel bad. You say that to a cat and they'll celebrate.
I don't care. Cats are still better.
Long, sharp claws.
Scary.
And their teeth are so sharp. Oh, good Lord. Scary. All right. I have an irrational fear of cats. I don't know if I've shared that with you or not.
I
Yeah.
didn't know that.
Yeah, no, it's irrational. I recognize that.
Okay.
But I still can't get past it. It just doesn't work. All right, and then this is another sample.
I love
That's on there. All right, what else do you want to talk about? Anything in this chapter that's confusing still? Doesn't make sense.
I'm just gonna ask this anyway.
Yeah.
I feel like
No, go ahead.
24. Does heating always cause a chemical change?
No, heating does not always cause a chemical change. Okay? So, for example, I can heat a cube of ice, right?
Oh.
I can heat that cube of ice. The ice is going to melt into water, but that's a phase change. That's not a physical change. We're just reducing the intermolecular forces between those molecules. I can continue to heat it until it's into a gas. It's still going to be water though. Okay. We haven't gone through any kind of chemical change. We've not rearranged any of those atoms. We've just weakened the force between them, the molecules. Okay. So heating doesn't always cause a chemical change. It does sometimes, like when you're cooking, different things like that, it'll cause a chemical change. But even you had your potassium chlorate the other day, right? That caused a chemical change. The oxygen came off of there. It's called a decomposition reaction. Okay, and you're left with potassium chloride, and the oxygen went away. So it wasn't potassium chlorate anymore. It was now potassium chloride. So you went from, just to give me some dead space here to write on, you went from KClO3. You rearrange this to make KCl and give off oxygen. Okay, that was in your crucible. This was the lab that you did in the crucible. This went off into the air. It didn't disappear. It didn't go away. It didn't get lost to the universe. Okay, it went up into the atmosphere.
Well, we have to remember like the suffixes for like oxygen and like hydrogen and that stuff.
So like
you said, like it changed from like an ite to like a.
You eventually will when we get into chapter 7, but you're not there yet. Okay. So this is potassium chlorate. This is potassium chloride. And we'll talk about how they get their names and all of that stuff's coming. Okay. But you do not need to worry about any of that stuff on this test. Now, if I said that you started out with 10 grams of this and you ended up with 7 grams of this, how much is this then?
8.
No, I started with 10 grams. I ended up with these two things. This is 7 grams. How much is the oxygen then?
3.
3. Because
I thought that
so
question
what
was-
you need to know for the test is that your starting reactants, because that's what these things are called, have to equal the mass of your products. That's what we're looking at, okay, for this test. You need to know that this side is called the reactants and that this side is called the products, and that the mass of both of those have to equal each other. Okay, but you don't need to know naming structure, formulas, anything like that yet. We'll get there.
So what would be the answer for number 27?
What is the question for 27? Assuming chemist is looking. Okay, so you had your chart here. So they were looking for something. Oh, yours is 20 and okay. So your questions were different than mine on this. I thought I had looked it over. Yeah, they would have found that because sample 1 would have been that. So they, on your thing, yours was, oh no, this is fine. This was fine. This was fine on yours. Can I go Control Z and get rid of that? Yeah, okay. This on yours was 20% A, right? And
Yes.
80% B. And they wanted to know if, so for this answer now, okay, the answer would be yes, they had found that in sample 1 because those percentages match up. So this would be the same as this 20 and 80, which is what appeared on your review. Owen?
Ours was like, how could the chemist determine whether he's successful?
So they would have to
Look at the
they would have to compare the percentages. And if the percentages were the same for both items, then they would have found it. Okay. But the answer is only sample 1, not sample 4. Sample 4 is not going to do her.
What about the 2 classifications of mixtures?
Homogeneous and heterogeneous are the 2 classifications of mixtures.
I should have known that.
Okay. Homogeneous is consistent throughout. You can't filter out particles of it. You've got to separate it through other means. But remember, all mixtures can be separated through physical means. We don't have to go through any chemical reactions to separate things. Good. What else you want to talk about? What else did I screw up on this thing? Because it seems like every point in turn I've screwed something up. Yes,
So
no.
27 would just basically use percent by mass formula.
Yeah, you just compare the percent by mass, and if they're the same, then it's the same substance. Other questions? Anything else that you can think of?